Hi everyone, this is Sai Teja from CSC AML section B. Today my topic is about characteristics equation of matrix. Let's go to introduction. Contents. The characteristic equation, linear algebra, matrix similarities, how to find the characteristic polynomial, how to find the characteristic polynomial of a 2 into 2 matrix, and how to find the characteristic polynomial of a 3 into 3 matrix. Finding the characteristic polynomial example problems. Let's go to introductions. Definition. Let A be a square matrix be, be any scalar, then is called characteristic equation of A. Note. Let A be a square matrix and be any scalar, then A minus lambda equal to 0 is called characteristic matrix. Mod of A minus lambda equal to 0 is called characteristic polynomial. The roots of the characteristic equation are known as characteristic root or latent roots. Eigenvalues are proper values of a matrix A. The characteristic equation. The term characteristic equation has various meanings throughout mathematics and its different branches. For example, there exists a characteristic equation in calculus, also called an axial equation, which is an algebraic expression emulating a homogeneous constant coefficients linear differential equation and thus having the same order as the differential counterpart, which has its main purpose to obtain the general solution to the original differential equation. Characteristic equation is about the existing equation in calculus and also called as an auxiliary equation, which is an algebraic expression emulating a homogeneous constant coefficients are also known as same order as the differential counterpart. The general solution to the original differential equation actually dedicates a few lessons on the calculus characteristic equation depending on the roots needed to solve it. If you are interested in checking this out, the first of a series of three is our lesson on the characteristic equation, which real distinct rules. The same can be said of characteristic equations used to find the general solutions to partial differential equations. To describe the term partial characteristic equation in simple words could be say this is a particular equation containing the main characteristics or elements such as the order of a large or more complicated equation. Usually for higher level math, in order to help solving the more complicated expression using simpler techniques. Characteristic equation linear algebra. Of the characteristic equation linear algebra method, we refer to the characteristic polynomial of a matrix equated to 0 as the characteristic equation of a matrix. Such equation is defined as det of A minus lambda equal to 0. We can see characteristic equation linear algebra. We refer to characteristic polynomial of a matrix equated to 0 as such that det of A minus lambda equal to 0. This is the characteristic equation linear algebra method. For equation 1, A represents the given n into n square matrix. Lambda is an eigenvalue of A. I is the n into n identity matrix. Delta of A minus lambda is the characteristic polynomial. You can see delta of A minus lambda equal to 0. In that equation, A represents the given n into n square matrix and lambda is an eigenvalue of A and I is the n into n identity matrix. Hence, delta of A minus lambda is the characteristics of polynomial. Matrix similarities. The characteristic polynomial of a 2 into 2 matrix happens to be equivalent to an algebraic second degree polynomial equation in terms of variable lambda. In other words, for a second order matrix, the characteristic polynomial is a quadratic equation for which we have to solve its roots, and such roots are our eigenvalues lambda. In general, the algebraic expression resulting as the characteristic polynomial will be of the same degree as the order of the given matrix A. The dimensions of A, and so depending on the order of A is the amount of eigenvalues and their corresponding eigenvectors that you will have to calculate. A equal to P inverse of Vp is the general algebraic expression resulting as characteristic polynomial will be the same degree as the order of the given matrix A. How to find the characteristic polynomial? In order to calculate an eigenvalue and its corresponding eigenvector for a given matrix A, we have to first find the characteristic polynomial of a matrix. So, in this section, we will learn how to find the characteristic polynomial for the two most common cases, A 2 into 2 matrix and the B 3 into 3 matrix. We usually focus on the matrix of these sizes because the calculations for the determinants of greater order matrices get extensive and are usually not asked for in assignments or general school lessons. But if you find yourself in front of a higher order square matrix for which you have to find its characteristic polynomial. How to find the characteristic polynomial of a 2 into 2 matrix? Let's see. First, we compute the subtraction of matrix A minus lambda. The result is a 2 into 2 matrix. Then we calculate the determinant of this resulting matrix. Remember, the determinant of a 2 into 2 matrix is calculated with the formula delta of A equal to AD minus BC. We can use this formula to determine the 2 into 2 matrix. Then the result is a quadratic equation as mentioned before in terms of lambda. You can use the delta of A equal to AD minus BC formula for the determinant of 2 into 2 matrix. How to find the characteristic polynomial of a 3 into 3 matrix? First, we compute the subtraction of matrix A minus lambda. The result is a 3 into 3 matrix. We calculate the determinant of this resulting matrix. Remember, the determinant of a 3 into 3 matrix can be calculated in two ways, the general method and the shortcut method. We recommend you to use the shortcut method to calculate this determinant. You can see the example how delta of A equal to how we can calculate by first of all we are taking diagonals as a positive of a1 B2 C3 plus B1 C2 A3 plus C1 A2 B3 of minus of A3 B2 C1 plus B3 C2 A1 plus C3 A2 B1. By using the formula of delta of A equal to AD minus BC, we can divide the table into given form. The result is a third degree polynomial equation as mentioned before in terms of lambda. Finding the characteristic polynomial example problems. Example 1. Find the characteristic polynomial of A equal to 257 minus 4. We start by computing the matrix subtraction inside the determination of a characteristic polynomial as follows. Here is the example of characteristic polynomial. How, how to find the characteristic polynomial of A? Let's see the example. 1. Delta of A minus I into lambda, that is equal to 2 minus lambda 5 7 minus 4 minus lambda equal to 0. Solving the determinant, we have that delta of A minus I lambda equal to 2 minus lambda into 2 minus lambda into minus 4. Solving the determinant, we have that delta of A minus I into lambda, that is equal to 2 minus lambda into minus 4 minus lambda minus of 7 into 5, that is equal to minus 8 minus 2 lambda plus 4 lambda plus lambda square minus 35 equal to 0. Delta of A minus lambda equal to lambda square plus 2 lambda minus 43. And so the characteristic polynomial of a 2 into 2 matrix given on this exercise is lambda square plus 2 lambda minus 43. Remember that if you were asked to calculate the eigenvalues for this matrix, you just have to use the quadratic equation to find the values of lambda. We can see the example one how the finding the characteristic polynomial of 2 into 2 matrix with the help of the formula delta of A minus I lambda equal to AD minus B AD minus BC. We can see example 2. Find the characteristic polynomial of A if A equal to 3 into 3 matrix 1, 5, 6, 0, 3, minus 1, 0, 0, 5. Starting up with the matrix subtraction A minus lambda, that is equal to A minus lambda equal to 1, 5, 6, 0, 3, minus 1, 0, 0, 5. Minus of 1 0 0 0 1 0 0 0 1 into lambda, that is equal to 1 minus lambda 5 6 0 3 minus lambda minus 1 0 0 5 minus lambda. We can see the example to how to find the characteristic polynomial of 3 into 3 matrix. We can see how we are supposed to doing the steps with with the help of the formula delta of A minus lambda equal to 0. With using this formula, we can solving the given A. Now setting up the determinant in order to calculate the characteristic polynomial expression delta of A minus I lambda equal to 1 minus lambda 5 6 0 3 minus lambda minus 1 0 0 5 minus lambda, that is equal to 0. Notice that the square matrix to which we are obtaining its determinant is a triangular matrix. Therefore, we can solve its determinant by simply multiplying the elements from its main diagonal. And so we solve for the final characteristic polynomial equation We can see the given given polynomial expression. There will be a determinant is a triangular matrix. So we can solve this determinant by simply multiplying the elements from its main diagonal. Let's see. Det of a minus I lambda equal to 1 minus lambda of 3 minus lambda of I minus lambda. That is equal to 1 minus lambda into 15 minus 3 lambda minus 5 lambda plus lambda square. Det of a minus lambda equal to 15 minus 3 lambda minus 5 lambda plus lambda square minus 15 lambda plus 3 lambda square plus 5 lambda square minus lambda cube. Det of a minus lambda, that is equal to minus lambda cube plus 9 lambda square minus 23 lambda plus 15. And finally, we get the 3 into 3 matrix by using the det of a minus I lambda. And also we got the expression determinant in a triangular matrix. Just we simply we multiplied the elements from its main diagonal. So we solve the final characteristic polynomial very easily. On this occasion, the characteristic polynomial is the third degree polynomial equation. We can see while solving the 3 into 3 matrix, the determinant is a triangular matrix. So we can solve the determinant by simply multiplying the elements from its main diagonal. By multiplying the main diagonal elements, and finally we got the degree third degree polynomial equation, that is minus lambda cube plus 9 lambda square minus 23 lambda plus 15. And here is the example of equation 2. We can easily identify the characteristic polynomial of a in 3 into 3 matrix. So we can simply using the formula we can do which type of matrix. It will be simply we can use the formula det of a minus lambda I equal to 0. With the help of the formula, we can do any type of matrix which is given. And we can see the example 1. In example 1, the characteristic polynomial is a 2 into 2 matrix. Just we simply subtracted inside the determinant of the characteristic polynomial, and then we simply got the answer as showing on the screen. You can see the final result. The characteristic polynomial is the third degree polynomial equation, that is minus lambda cube plus 9 lambda square minus 23 lambda plus 15. This is the Final characteristic polynomial in the third degree polynomial equation. Thank you all.